A few days ago, the European Space Agency quietly released new data from the ExoMars Orbiter, and what they found has scientists around the world buzzing. On one of its orbits around Mars, ExoMars' onboard camera captured something remarkable: the interstellar visitor now known as 3I Atlas, first discovered on July 1st, 2025. At first, it looked like just another faint object moving through space. But as astronomers studied the data, it became clear that this was something different, something anomalous. The object is large, bright, and curiously aligned with the orbital plane of the planets around the Sun. In other words, it's traveling right along the same flat plane where every major planet orbits. That's unusual. And for researchers, it's a gift, a rare cosmic alignment that allows multiple spacecraft and observatories to study it at the same time.
Just a few days ago, on October 3rd, 3I Atlas passed near Mars, within 29 million kilometers of the red planet. During that encounter, ExoMars' camera detected it clearly, appearing as a bright ball of light with a faint extension. But here's the strange part. It doesn't look like a normal comet. Normally, a comet shows a long, graceful tail streaming away from the Sun, made of dust and gas pushed by solar radiation. Atlas doesn't do that. Instead, it shows a short extension that actually points toward the Sun, almost as if there's a luminous jet firing into the sunlight. That's not supposed to happen. In fact, this same odd feature showed up earlier in July when the Hubble Space Telescope captured its own image of 3I Atlas. The pattern was identical: a bright concentrated core, not diffuse, not dusty, and a strange faint extension that seemed to point toward the Sun rather than away from it. It's almost as if something is driving light and material sunward, pushing against the direction of radiation pressure, the exact opposite of what every physics textbook tells us a comet should do. That's why researchers are so fascinated, because this isn't just a pretty picture, it's a physics problem. Why would a natural object behave as though it's emitting light or material against the solar wind? Is it a jet, some internal venting mechanism? Or could it be a highly reflective structure that's simply scattering light in a way we've never modeled? The truth is, no one can say for sure yet. Now that 3I Atlas has passed near Mars, we're expecting much higher resolution images soon. And the best, truly, is yet to come. The HiRISE camera, onboard NASA's Mars Reconnaissance Orbiter, took a detailed set of photos during the object's closest approach. HiRISE carries a half-meter wide mirror, enormous for a spacecraft camera, and can achieve resolutions of about 30 kilometers per pixel from its current distance. That's sharp enough to tell us a lot about Atlas's structure, how its brightness is distributed, how smooth or jagged its surface might be, and even whether it's surrounded by a concentrated cloud or halo. In other words, every pixel matters. The brightest pixel in those upcoming images will reveal how efficiently 3I Atlas reflects sunlight. From that, astronomers can estimate its true size, density, and reflectivity, and even get clues about its composition. Are we looking at ice and dust, or something metallic and unusually polished? Everyone across the planetary science community, from NASA to ESA to independent observatories, is waiting for that first public release. Because sometimes one photograph doesn't just answer questions, it changes the entire conversation. And as the saying goes, a picture isn't just worth 1,000 words. Sometimes it's worth rewriting the textbook. Unfortunately, there's a catch. Because of the ongoing US government shutdown, many NASA data streams and websites have gone dark, right in the middle of this once-in-a-lifetime event.
So while the Mars Reconnaissance Orbiter did collect the data, that information hasn't been made public yet. Researchers working with the data are processing it at universities, but they're not allowed to release anything until the government reopens and NASA systems come back online. Some people online have asked whether the delay means NASA is hiding something, maybe evidence of alien technology. But according to astrophysicist Avi Loeb, the answer is less dramatic. He joked that this isn't a sign of extraterrestrial intelligence, it's a sign of terrestrial stupidity. In other words, politics, not aliens, are holding up the data. Still, the excitement around 3I Atlas is completely justified. This is the first time we've had such clear, multi-mission coverage of an interstellar object inside our solar system. After leaving Mars behind, Atlas will swing close to the Sun at the end of October, reaching perihelion around the 29th to 31st. That's when the real test begins. The Sun will heat it to extreme temperatures, bombard it with radiation, and we'll see how it responds. Will it flare up dramatically, fragment, or stay intact? That's the big question. Then, as it moves outward again, 3I Atlas will make a close pass by the JUICE spacecraft on its way toward Jupiter in November. JUICE, short for Jupiter Icy Moons Explorer, might even be able to observe the object as it races past. And by December 19th, just before Christmas, it will be at its closest point to Earth, roughly 1.8 astronomical units, or about 270 million kilometers away. After that, in March 2026, it's expected to pass within 54 million kilometers of Jupiter, where NASA's Juno spacecraft could also have a chance to gather data. So, over the next few months, this interstellar visitor will give us an extraordinary series of opportunities, multiple spacecraft, multiple perspectives, and perhaps multiple surprises. Why does it matter so much? Because we've never seen an interstellar object like this before, this large, this reflective, this well-aligned with our solar system's orbital plane. It challenges our understanding of how material moves between stars. And if it turns out to have any artificial characteristics, it could rewrite our understanding of what's out there. Avi Loeb has even written a white paper to the United Nations, proposing the creation of an international committee to analyze future interstellar detections. The idea is to coordinate global data, so when the next visitor appears, we can study it immediately and perhaps recognize signs of something beyond a simple rock or icy fragment. He also suggests establishing a new wide-field observatory in the Northern Hemisphere to complement the Vera Rubin Observatory in Chile. That would allow us to monitor the entire sky, north and south, catching more of these fast, faint objects before they vanish back into the dark. The cost? About $1 billion, roughly the same as Rubin itself. And if we ever did confirm that one of these visitors was technological, an alien probe, for example, the investment would instantly multiply 1,000-fold because the implications would reach far beyond science. It would touch global security, economics, and the very question of our place in the universe. Loeb puts it poetically, the question, are we alone, is the most romantic question in science. And if one day we find a partner, another civilization out there, it could completely redefine who we are. But, he jokes, let's just hope that when we finally meet them, it's not a blind date with a serial killer. In the end, that's why 3I Atlas matters. It's a wake-up call, a reminder that our solar system is not isolated, that other star systems can send visitors, and that some of those visitors might carry surprises we're not ready for. So as this object races toward its encounter with the Sun, and as we wait for NASA's images to finally go public, we stand on the edge of another turning point in our understanding of the cosmos. Stay curious. Stay patient. And if you want to keep following this mystery as it unfolds, make sure to subscribe, because this story, the story of 3I Atlas, might just be the first chapter in something far bigger than we ever imagined.